Okay, so in this video we're going to be looking at two special matrices. One's called the identity matrix and one's called the inverse matrix. So what I want you to do is I want you to have a go at expanding those two 2x2 matrices and get your answer. So pause, and when you're ready come back live. Okay, so let's change to pen. So we're going to have 5 times 1 is 5, 2 times 0 is 5, and we keep going that, and we should get that. And in the second matrix, we've got 1 times minus 2, and 0 plus minus 3 is minus 2, and etc. We should get that. So what I'm trying to say is, we started with that matrix, and we got the same answer. And we had this matrix at the back, and we got the same answer. And the only thing that was the same was these two matrices, 1, 0, 0, 1. Okay, so that's what we need to look at. So what these matrices are called, this 1, 0, 0, 1 for a 2x2, or even though we're not studying it this year, a 3x3 would be 1, 0, 0, 0, 1, 0, 0, 0, 1. So this diagonal is 1s, and we call that the leading diagonal. Okay, leading diagonal, and everything else is zeros. Now when you have that matrix, that's a special matrix because it doesn't change. When you multiply, it doesn't change the other matrix. Okay, and this matrix is called the identity matrix. Okay, just like, you know, if you had 5 times 1 equals 5, okay, 5 is a number that doesn't change. 1 is a number that doesn't change anything. In matrices, this identity matrix doesn't change anything, and the notation for that is the letter I as a capital. Okay, now for the time being, all you need to know is that the identity matrix is a leading diagonal of 1s and everything else is zeros. Okay, so copy that, and when you're ready, come across. Okay, so the special property of the identity matrix is it doesn't matter if it's at the front or the back, you still get the same matrix, and that's what you found when you did the multiply. Okay, so it doesn't matter where I is placed, you just get the matrix back again. Okay, so copy that and come across. Okay, so we're going to use what we've just learned about identity to help us find what's called the inverse, and the inverse is a useful, very useful matrix for solving equations. So just for the time being, we're only doing 2x2 matrices. There's inverses for 3x3, but we don't do it in this unit. So for the time being, could you just multiply those matrices and see what answers you get? So pause and come back when you're ready. Okay, so you're back. So 5 times 1 is 5. 1 times minus 4 is minus 4. 5 minus 4 is 1. 5 times minus 1 is minus 5. 1 times 5 is 5. And you get 0. 4 times 1 is 4. 1 times minus 4 is minus 4. Add them to get 0. 4 times minus 1 plus 5 is 1. And similarly, hopefully, 1 times 3 minus 2 is 1. 1 times 1 minus 1 is 0. 0, 1. Now, that matrix is the identity matrix. So what do you notice about the numbers in the second matrix compared to the first matrix? So just have a look and see if you can see any patterns. Pause, and then when you're ready, come back. Okay, so it doesn't matter if you didn't quite see it, but if you have a look at the leading diagonal, okay, 5, 1, 1, 5, look at the leading diagonal, 1, 3, 3, 1, okay, so the numbers have switched over. And in the other diagonal, which is called the alternate diagonals, the number 1 has changed to minus 1, the number 4 has changed to minus 4, the number minus 1 has changed to 1, and minus 2 has changed to 2. So the pattern at the moment, because it's not really going to hold forever, the pattern is that in the leading diagonal, the numbers have switched numbers. And in the other diagonal, called the alternate diagonal, the signs have changed. So that's one thing you should have noticed, or could have noticed, or might have noticed. Okay, so let's have a look at another example. So what I've done here is I've got the leading diagonal changed and the other numbers have changed sign, but let's do the multiply and see what happens. Okay, so pause, and when you're ready, come back live. Because at the moment, everything's in the right spot, but let's see what happens. Okay, you might be back. Okay. So we've got 5 times 4 is 20. 5 times 4 is 20, minus 3 is 17. 5 times minus 1, 1 times 0 is 0. 3 times 4 is 12. 12 minus 12 is 0. 3 times minus 1 is minus 3, plus 20 is 17. So we've got 17, 0, 0, 17, and it doesn't look quite like what we had just a second ago, but if you take the fraction 1/17 out, you get 1, 0, 0, 1. So suddenly there's this number that's part of it, and this is the inverse of a 2 by 2 matrix. Okay, it has to have an actual fraction out the front. It was just in the previous ones that the fraction out the front was 1/1. Okay, and that's why it didn't change, but now we have a 1/17. So let's have a look at the general case, not specific examples. Okay, so the specific general case, sorry. If one matrix is A, B, C, D, the inverse, which is A minus 1, is you have to do this calculation of AD minus BC to get the fraction that comes out the front. So what we do is we multiply the leading diagonal, and then that's the leading diagonal, and then we multiply the alternate diagonal and we subtract. So in that previous example, 5 times 4 minus 1 times 3 equals 20 minus 3 equals 17, and that's where that number there comes from on the bottom. Okay, so this little formula is the formula for the inverse. So you get the fraction out the front, and it's always 1/, and then you switch the diagonal, switch the leading diagonal, and change the sign on the alternate diagonal. And the property is a matrix multiplied by its inverse, or an inverse multiplied by the matrix, always equals I. Okay, so copy that down, and we'll do some examples in the next slide. Oh, before we do an example, just this expression as part of the denominator. So that expression there, which is 1/AD minus BC, blah blah blah, this part of the number is called the determinant of the matrix, and in some textbooks they just use a triangle as the notation. Okay, so if you see a triangle, it just means find the determinant, AD minus BC. Now, if AD minus BC equals 0, you can't divide 1 divided by 0. You can't divide by 0, and so for this particular case, the inverse does not exist. It doesn't have an inverse, and in this particular case, it's called a singular matrix. Okay, so you don't have an inverse because you can't divide by 0. So AD minus BC is called the determinant. It's not the fraction, it's the denominator of the fraction, and if the denominator equals 0, you can't divide by 0, so there's no inverse. So copy that and come across. Okay, so now we're going to do some inverses. So we're just going to use that formula, the formula being 1/AD minus BC, and then ABCD turns into D minus B minus C A. Okay, so just use that, and when you're ready, come back. Okay, so in this particular one, we've got 1/3 times minus 5 is minus 15, minus 2 times 1 is minus 2, and we'll clean that up in a sec. And then these two numbers switch positions, so minus 5, 3 switch positions, and minus 2, 1 change sign, and then we just got to tidy this up. So it's minus 1/13, minus 5, 2, minus 1, 3. Okay, so next one, we get 1/5 fours are 20, minus 20, and then it doesn't matter, this isn't going to work. So 4, 5, minus 10, minus 2. So 1/0, therefore there is no inverse. So it's therefore called a singular. It has no inverse. Okay, and you'll notice that if the numbers, these numbers, if they multiply to the same number, when you subtract, you'll get a 0. So that's the pattern there. Okay, And that's the end of the slide. So you'll be getting some exercises on finding inverses. Thanks, bye.